Now in the last lesson, we have looked at the basics of chemical calculations, namely the 3C approach that will allow you to solve 90% of chemical calculation questions. For this lesson, we're going to look at a shortcut that we can use when we are dealing with gases, meaning when we are dealing with reactants that are gases, products that are gases. So let's do a review of the 3C approach. Now in this question, we are looking at the formation of ammonia from nitrogen and hydrogen, right? And then we are given that 20 centimeter cube of nitrogen was reacted completely. Alright, so now the question requires us to find the volume of ammonia formed and the volume of H2 that is reacted. Okay, we can use the 3C approach again to solve this question. So let's try it. Step number 1, which is to convert to moles. Okay, what are we given? We are given the volume of nitrogen. So we can convert volume of nitrogen into number of moles of nitrogen, which is 20 divided by 24,000. Okay, this is volume divided by molar volume. If you can recall, the molar volume of any gas is 24 dm cube, and to convert dm cube in centimeter cube is equivalent to 24,000 cm cube. Okay, so that will allow us to find that the number of moles of nitrogen is this. Okay, so step number 2 is to compare mole ratio. Compare mole ratio between what is given, which is nitrogen, and what we want to find. In part A, we want to find ammonia. Okay, so the mole ratio is as follows. 1 mole of nitrogen will give 2 moles of ammonia. So number of moles of ammonia will be equals to 2 times the number of moles of nitrogen, which will give us this value, 0.00167 moles. Okay, step number 3, we need to convert from moles. So the question wants the volume of ammonia. So now we need to convert number of moles back into volume. So how do we do so? We multiply by the molar volume. Okay, I've written it as 24,000 because I want the final answer to be in centimeter cube, and the final answer is 40 centimeter cube. Okay, let's do the same for part B. For part B, what is the volume of hydrogen reacted? Okay, so step number we can jump straight to step number 2. Step number 2, we need to compare mole ratio between what is given, okay, nitrogen, and what we want to find, which is hydrogen now. Okay, so 1 mole of nitrogen reacts with 3 moles of hydrogen. That will mean that the number of moles of hydrogen reacted is 3 times that of the number of moles of nitrogen. Okay, then step number 3 is the same. We need to convert from moles. Now we need to find volume of hydrogen, so we take number of moles multiplied by 24 dm cube. That will give us 60 centimeter cube. Okay, so this is another example of how the 3C approach can be used to solve a chemical calculation question. However, as mentioned, there is actually a shortcut to solving this question. We don't have to go through the 3 steps when a chemical reaction involves gases. Okay, and we have one person to thank. Person is called Avogadro. Alright, I know the name sounds familiar. Your Avogadro number came from the same scientist. Okay, now Avogadro found this, that for reactions involving gases, okay, very importantly, can you all remember this, that mole ratio is equals to volume ratio. Okay, now what do I mean by that? So let's look at the same reaction just now, ammonia plus nitrogen plus hydrogen gives ammonia. So we have seen that they are all gases. So from the balanced chemical equation, we can tell that 1 mole of N2 reacts with 3 moles of hydrogen to produce 2 moles of ammonia. Since they are all gases, it simply means this: one unit of volume of N2 will react with 3 volumes of H2 to produce 2 volumes of ammonia. Okay, if volume is too abstract for you to understand, it simply means this: if I have 1 centimeter cube of N2 undergoing reaction, it will react with 3 centimeter cube of hydrogen to produce 2 centimeter cube of ammonia. Okay, so bearing this in mind, mole ratio equals to volume ratio, let us see how we can solve the problem very quickly. So back to this example, I have 20 centimeter cube of nitrogen reacting with hydrogen to form ammonia. They are all gases. We have now learned that the mole ratio, that means 1, 3 and 2, is also equivalent to the ratio of the volumes. So straight away, without using any calculators, I'm sure most if not all of you all will be able to tell me that the volume of hydrogen required is 3 times that of 20, so it's 60 centimeter cube, and the volume of NH3 form is 2 times that of N2, so it's 40 centimeter cube. Okay, so by simply applying Avogadro's relation, what is Avogadro's relation is for reactions involving gases, the mole ratio in which they react is equivalent to the ratio of volumes in which they react. Alright, so by applying Avogadro's relation, there's no need to perform any elaborate calculations. We can tell straight away just by using the ratio to multiply by the volume. Alright, so this is a very quick method, but bear in mind that it will only work when what is given and what we want to find are both gases. Okay, now let's try to apply Avogadro's relation on another question. So in this question, we are looking at a gas with the molecular formula C2H3F3. Alright, it's called trifluoroethane. Okay, this gas is trifluoroethane. I'm going to use the abbreviation TFE to represent it. Okay, so in this reaction, TFE reacts with oxygen to produce carbon monoxide, water and fluorine. Alright, so the question wants you to find the volume of O2 reacted. Now TFE is a gas, O2 is a gas, so we can apply Avogadro's relation here, where mole ratio equals to volume ratio. So 4 moles of TFE will produce 7 moles of O2. If I have 10 centimeter cube of TFE, what is the volume of O2 that will be produced? We simply use the mole ratio, which is 7 over 4 times 10. That will give us a value of 17.5 centimeter cube. Okay, so you can see over here, since the reactant and the or since the whatever that's given and whatever that we want to find, they are both gases, there's no need to go through the 3C approach. We can simply use the mole ratio directly to find volume. Okay, so for part 2, now we are looking at CO, which is carbon monoxide. Carbon monoxide again is a gas, so whatever that's given, TFE is a gas, whatever that we want to find, CO, is also a gas, so we can use Avogadro's relation. 4 moles of TFE produces 8 moles of carbon monoxide. Okay, so essentially the mole ratio is 1:2. 1 mole of TFE will give me 2 moles of CO. Right, so volume of CO is actually equals to 2 times the volume of your TFE, which is 20 centimeter cube. Alright, so once again, if in a chemical calculation question, whatever that's given and whatever that you want to find, they are both gases, then we can use Avogadro's relation, where volume ratio or molar ratio is equals to volume ratio. Even more so if the whole reaction involves gases. Gas reacts with gas to form another gas, then the molar ratio as shown in the chemical equation is simply the volume ratio. Now this is very important to remember, especially in MCQ questions, where usually they don't require you to do very lengthy working. Alright, so in MCQ, please take note, please try to look out if the reactants and products are all gases and whether you can apply Avogadro's relation to solving it.